find the general solution to the ODE y double prime minus y prime minus 12y equals 0. So as usual, constant coefficient, second order linear difference, homogeneous difference equation, we're going to guess y equals e to the rx, right, where r is a constant. And then we're going to try and figure out the value of r to actually solve the difference equation. All right, so let's calculate derivatives. Right, that's y prime is going to be r e to the rx. Y double prime is r squared e to the rx. Plug that into the difference equation here, so I get r squared e to the rx for the y double prime term. Got minus y prime, so minus r e to the rx. And I got minus 12 times y, so just e to the rx. That all equals 0. Then I factor out e to the rx, so I get r squared minus r minus 12 e to the rx equals 0. And right, I can't set a value of r to get e to the rx equal to 0, so I have to pick a value of r to get this polynomial equal to 0. By the way, that polynomial is called the characteristic polynomial. Characteristic. And you actually don't need to go through these steps every single time. I've done it here just for clarity. So right, the polynomial you'll end up with is just the term in front of the y double prime times r squared, and then the term in front of the y prime, here it's negative 1 times r, and then you have the term in front of the y, so just the minus 12 with no r. And that will be the characteristic polynomial every single time. All right, so now the idea is we want to solve for the roots in order to figure out the solutions that work for this ODE. And maybe you could do that in your head, maybe not. I'm going to go ahead and use the quadratic formula. So right, the quadratic formula here, we have a is equal to 1, b is equal to negative 1, and c is equal to negative 12. If I plug that in, the formula is negative b plus or minus square root of b squared minus 4ac over 2a. Right, and if I go ahead and plug those in, I end up with, let's see, so negative b, so I get positive negative 1, so positive 1, plus or minus the square root, so b squared, so negative 1 squared, that's a 1, positive 1. We got minus 4 times a, which was 1, times c, which is negative 12. All right, and on the bottom here, I get 2 times 1. Let me just go ahead and finish that up on the side. So let's see, I have 1 plus or minus square root. Okay, I've got, what is that? Negative 4 times negative 12, that ends up being positive 48. So I have 1 plus 48, over 2. Okay, well that ends up being 1. So that ends up being the square root of 49. Right, so 1 plus or minus square root of 49 over 2. Well, that's 1 plus or minus 7 over 2. And I think I can squeeze it in the bottom here. Well, that ends up equaling, what is that? Let's see, 1 plus 7 would be 8 over 2. And then 1 minus 7 would be negative 6 over 2. So it ends up being 4 and negative 3. And that looks plausible, so I should have this thing here, r squared minus r minus 12 is equal to r minus the first root here, so r minus 4. Then I've got r minus the second root, negative 3. So that ends up being, right, r minus 4 and r plus 3. And yeah, I think that works out. R times r, that gets me the r squared. I have a negative 4r and a plus 3r. That gives me 1 negative r. Yep. Then I have negative 4 times negative 3 will be the negative 12. Yeah, that works out. All right, so then our roots, right, we have y1 equals e to the r1x. Here I'll say r1 is the positive 4, and r2 is the negative 3. Right, and then we have y2 equals e to the r2x. So those end up being e to the 4x, and that's e to the negative 3x. Really quickly, let's just go ahead and plug those in and see why they work. So right now I have e to the 4x, then I have y1 prime, that's 4 e to the 4x. And I have y1 double prime, that's 16 e to the 4x. And if I plug that in, so right, I have y1 double prime minus y1 prime minus 12 y1 from the original ODE. Well, that's going to end up equaling, let's see, so that's 16 e to the 4x minus 4 e to the 4x minus 12 e to the 4x. And yeah, that definitely equals 0, right? 16 minus 4 minus 12 is 0. Over here, for y2, if I go ahead and calculate the derivatives and plug them in, I get y2 prime equals negative 3 e to the negative 3x. And y2 double prime is 9 e to the negative 3x, right? Negative 3 times negative 3 is positive 9. Plug it in, right? So original differential equation is y2 double prime minus y2 prime minus 12 y2. Okay, well that ends up equaling, let's see, 9 e to the negative 3x minus negative 3, so plus 3 e to the negative 3x. Then I have minus 12 e to the negative 3x. And yeah, that does equal 0. So they both work. And then the general solution, let me go ahead and put that over here. The general solution is any linear combination of those. So we'll have y of x equals c1 y1 of x plus c2 y2 of x. Sorry, I had to squeeze that in, which equals c1 e to the 4x plus c2 e to the negative 3x.